All right, continuing with example 2, we're going to use the same thing, but we're given a different initial value. So we're going to have y equals, y of 0 equals 1, and so our x value is going to be 0, our y value is going to be 1, and we're doing it of the same function, y equals 1 over x squared plus c. So our y value is 1, and then 1 over x squared, our x value is x plus c. That's going to give us, when we simplify, 1 is equal to 1 over c, and so that means our value is c equals 1. Well, if c equals 1, then here is our solution, 1 over x squared plus 1. There's our solution where we solved for c. And also, what's the largest interval? Well, there's no way that denominator is going to equal 0. And because there's no way that denominator is going to equal 0 under the real numbers, system, then what we're going to have is negative infinity to positive infinity. So you're going to see, oh, this isn't too bad. Today is going to be very easy. The next part, example 3, x equals c sub 1 cosine t plus c sub 2 sine of t. It's a two-parameter family of solutions of the second order differential equation. X double prime plus x equals 0. Find the solution of the second order initial value problem consisting of this differential equation and the given initial conditions. All right, so they give us, what x and x prime are when x is equal to, or in this case, t is pi over 4, then x will be square root of 2 and 2 square root of 2. So what we're going to do here, it gives us the solution to the differential equation, x double prime plus x equals 0. It already gives us that. So what we're going to do is we're going to determine, okay, what's the two parameters that we need to solve for? C sub 1, C sub 2. That's why it's called two parameter, because we need to solve for C sub 1 and C sub 2 are two constants. So the first thing I'm going to do is I'm going to find x prime, because I already know I can plug some values in for x prime. So taking the derivative, c sub 1 cosine of t is going to be negative c sub 1 sine of t. And then plus the derivative of sine t is cosine t, so c sub 2 cosine t. And then I'm just going to plug in my value. So I'm going to go ahead and plug in this first one. I'm just going to do it in pink. I'm going to plug it into the original. So I get radical 2 is equal to c sub 1 times cosine of t. So c sub 1 cosine of pi over 4. It's just radical 2 over 2. Plus c sub 2, which is going to be sine of pi over 4, which is also radical 2 over 2. And then over here in red, I'm going to go ahead and substitute in that value into my derivative. So we're told that the derivative is 2 radical 2 when t is pi over 4. So I get negative c sub 1. Pi over 4 into sine t is going to be radical 2 over 2. And then plus c sub 2, radical 2 over 2 as well. All right, well, this is nice because right now I have a system of equations. I have two equations right here. So I know how to solve a system. What I'm going to do is I'm just going to go ahead and bring, my derivative over, and I'm just going to add these. So I'm going to solve by, not elimination, but by, by elimination. So I'm just going to bring over my derivative. 2 radical 2 is equal to negative c sub 1 radical 2 over 2 plus c sub 2 radical 2 over 2. And I'm just going to add them. When I add these, I'm going to get 3 radical 2. Oh, my iPad freaks out. 3 radical 2 is equal to... the c sub 1s are going to cancel out. We're square root of 2 over 2 plus square root of 2 over 2 is just going to be it's just going to be square root of 2. So we get c sub 2 is equal to, c sub 2 square root of 2. Get rid of the square root of 2 by dividing both sides, so we're told that 3 is equal to c sub 2. Now, what I'm going to do is I'm going to substitute this into either of those equations. It doesn't matter which one. I'm going to go ahead and substitute it into the... oops, went too far there. Erased too much. All right. So I'm going to go ahead and just substitute back into the first. So I get radical 2 plus C, oops, not plus, equals C sub 1 radical 2 over 2 plus, we know what C sub 2 is, it's 3 radical 2 over 2. I just substituted into that one, all right, to solve for C sub 1. Now, I'm just going to multiply everything by 2 just to get rid of fractions. So I get 2 radical 2. You don't have to do it. You can choose whatever way you want to solve for this. Plus 3 radical 2. Subtract both sides by 3 radical 2. I get negative radical 2 is equal to C sub 1 radical 2. Divide both sides by radical 2. And so C sub 1 is equal to negative 1. And so we have a solution. I'm going to do that solution in green. And our solution is going to be x is equal to C sub 1 is going to be negative cosine t plus C sub 2, which is going to be 3 sine of t. And so there's my solution.